Dear students, good morning. Er.M.N.Ramdas. I welcome you to my channel, Maths from Basics for You. So, my funda is learn maths from basics and be good in mathematics. See, what I would like to tell you something very important. I have noticed some students ignore differentiation and integration in the classrooms and even in the examinations. So remember this, mathematics without differentiation and integration is nothing. So you have to be good in mathematics, be good in differentiation and integration if you have to be good in mathematics, otherwise it will be difficult for you. For students who are interested to get into engineering, differentiation and integration is must and you have to. So you don't have to worry, I am there to teach you maths from basics. I promise even the weakest student in the classroom will follow my lecture and he'll be good in mathematics. So bank on me and follow my class regularly without fail. So by doing so, you be sure that you'll be good in mathematics. So we are going to start mathematics right from basics. So today I'm going to start differentiation, and we should know what is differentiation. To begin with, differentiation is nothing but a process to find the derivative of a function. So, for instance, if y equals to f of x, so this is y equals to f of x, where y equals a dependent variable which depends upon the values of x. So here y is a dependent variable, f is a function and x is an independent variable. So let me make a note on this so this is dependent variable and x is an independent variable. Independent variable and f is nothing but a function. So y is a dependent variable, x is an independent variable, f is a function. So at a later stage I will tell you about functions, how many types of functions are there. There are totally 5 functions: constant function, algebraic functions, log functions, trigonometric functions and exponential functions. We shall study this at a later stage, perhaps in my next class, but I want you to be very alert because I am going to do some formulas on differentiation which is a must for you to remember. Otherwise, if you don't remember these formulas, you cannot get into mathematics and you will not be good in differentiation. So know these formulas by heart, and anytime I ask you, you should be able to recollect and write it in your book or in your notes. So we'll start with differentiation and its formulas. So I'll rub this, please make a note of this. So I'll rub this. Formulae on differentiation. So there are some important formulas. That is, formula is singular, formula is plural. So formula singular, formula is plural. So you need to remember this formulae for differentiation. So first one. Before this, I would like to say something very important which I have noticed in the classroom as well as in the examinations while correcting the answer sheets. See, usually what has happened is, supposing You are given a function y like x, so that is y equals x to the power of n. So we have a function y equals x to the power of n. You have to differentiate this with respect to x. The procedure is very simple. Just observe here. See what you have to do. You have to differentiate it with respect to x, that is dy by dx equals to, you have to write d by dx of x to the power of n. So this is the right procedure where you are differentiating this function with respect to x and you are about to differentiate this. So it means to say now you are ready to differentiate this. So what I have noticed, some students what they do is they write this dy by dx equals to, again they write dy by dx to x to the power of n. So this is wrong. You cannot use dy by dx on left hand side and again use dy by dx for differentiating to this. This means to say the same thing. So you can't use the same thing here. So the right method is you have to use dy by dx equals to d by dx of x to the power of n. So not this, not this, this is wrong. So remember this, this is dy by dx and d by dx which you are bound to use while differentiating. Never use this while differentiating, you lose all your marks. So make a note of this. So this is an important issue what I have noticed while in the classroom as well as in the engineering answer sheets. So when I am correcting this, I have noticed this. Please don't do this. So we'll see what if we differentiate all this, what we get now. So I'll rub this. Please be informed not to commit this mistake. Okay, I'll rub this. First one, first formula, that is d by dx of a constant. If you differentiate a constant, you get 0. That is, differentiation of constant is 0. So that is 0. Differentiation of constant is 0. Second one, d by dx of x equals to 1. So if you differentiate d by dx of x, it is 1. Third one, d by dx of 1 by x. This is nothing but minus 1 by x square. So if you differentiate 1 by x, you get minus 1 by x square. I will show in later stage how you get this later on, but until now please copy this. We will discuss this in detail. Fourth one, d by dx of root x is nothing but half root x. So if you differentiate d by dx of root x, we get half root x. And very important formula here, d by dx of x to the power of n. So what happens if we differentiate x to the power of n? This is n into x to the power of n minus 1. So if you differentiate d by dx of x to the power of n, we get n into x to the power of n minus 1, where n is a real number, where n is a real number. N is a real number. A real number. So next, sixth one, d by dx of log x to base c. If we differentiate d by dx of log x to base c is 1 by x. So, if we differentiate log x to base c is 1 by x. Seventh one, d by dx of e is nothing but 0. So, you differentiate d by dx of e, you get 0. It is similar to a constant, it is an exponential. So, the value of e equals to 2.7182. The value of e is 2.7182. Eighth one, d by dx of e to the power of x. This is exponential. So, if you differentiate this, you get e to the power of x itself. So, the differentiation of e to the power of x is as same as it is e to the power of x. Now, ninth one, d by dx of e to the power of ax. If you differentiate e to the power of ax is e to the power of ax into a. This is nothing but a into e to the power of ax. Now, 10th one, d by dx of a to the power of, x to the power of a. This will be a into x to the power of a minus 1. So, it is similar to this. So, note this. Now, we will go to the next important formula, that is t by dx of a to the power of x. Here x to the power of a, here it is a to the power of x. Let us see what happens. If we differentiate this, we get a to the power of x log a to base e. So, if you differentiation of d by dx of a to the power of x is a to the power of x into log a into log a to the base e. Next one, 12th one, d by dx of a to the power of 2x. So, this is nothing but a to the power of 2x into 2 log a to base e. So, nothing but you get the coefficient of this a to the power 2x into same as log a to base e. D by dx of log x to base a. So, if we differentiate log x to base a, here we have log x to base e. Where is that? Here. But in this case, it will be 1 by x log e to base a. Remember this, log x to base a is 1 by x into log e to base a. This, instead of 5 to the power of 3x, this is 5 to the power of 3x into 3 log a to base e. Log a into base e. So, this and this are quite similar. So, sorry, here you write it 5 to the power of e. Now, in the event if I have missed some formulae, I will try to add on when I am doing the problems. Now, we will see what happens to trigonometric functions. What are trigonometric functions? Trigonometric functions are nothing but sin A, cos A, I will tell sin theta, cos theta, then tan theta, cot theta, secant theta and cosecant theta. Now you will be wondering, first time you are hearing this, what is sin theta, cos theta and all these things, which I am going to teach you. If you differentiate sin theta, what happens in all those things little later. But now you try to remember this formulae, which is very important for you. But for this, it will be difficult for you to do your problems when you are dealing with trigonometric functions. So let us come to know. Now before that, now I write this trigonometric functions. Trigonometric functions. First one I will take d by dx of sin theta. So if you differentiate d by dx of sin theta, you get cos theta. So if you differentiate d by dx of sin theta, you get cos theta. Now there is a small problem here. You will ask me, okay sir, sin theta, if you differentiate, you get cos theta, but what is this theta, which had happened to me also. So let me tell you an incident which had happened with me when I was a student. So in the classroom, what happened when he was teaching me, when my lecturer was teaching me problems on this topic, that is trigonometric ratios. So it almost, the chapter was getting over, I got up and said, sir, by the way, out of this, what is theta, sir? So he smiled and said, whatever is said, I am going to tell you right now. So like in English, we have some alphabets A, B, C, D, E, F, etc. Similarly, we have some Greek alphabets like alpha, beta, gamma, theta, etc. So this is nothing but a Greek alphabet theta. So we are going to use this cos theta. You can use in cos x, sin x, other things, or sin A, cos A, all the things, but let us stick on to this theta. So if I differentiate d by dx of sin theta, we get cos theta. Second one, d by dx of cos theta. If I differentiate d by dx of cos theta, we get what? Minus sin theta. So d by dx of cos theta is minus sin theta. So I am going to rub this, please make a note until then. Now, third function, that is d by dx of tan theta. So if you differentiate tan theta, what do we get? We get secant square theta. So secant square theta. Now next, so know this, fourth one, d by dx of cot theta. See, cot theta is nothing but the reciprocal of tan, which I am going to teach you later. So if you differentiate cot theta, what happens is we get minus cosecant square theta. So you get minus cosecant square theta. Fifth one, d by dx of secant theta. What is secant theta? It's a reciprocal of cos theta. So I'll tell you later. So this is minus, this is secant theta into tan theta. So if you differentiate secant theta, we get secant theta into tan theta. And last one, d by dx of d by dx of cosecant theta. If we differentiate cosecant theta, we get minus cosecant theta into cot theta minus cosecant theta into cos theta. So one thing I want you to look at this, d by dx of cos x, the letter cos starts with c. When we get cos theta, that is c, we get a minus value. So whenever you are differentiating some function, cos or cot or cosecant, we start from letter c. See, here also it starts with letter c, so you get a minus value, right? Likewise, when you are differentiating d by dx of cot theta, here you get again minus cosecant square theta, because here also to begin with the letter is c. And look at this, d by dx of cosecant theta is minus cosecant theta into cot theta. Here also c, you get once again minus. So remember this, you will not go wrong when to use minus in all this. But this is different, this formula will change when you are doing integration. Let's not bother on that now. So remember these formulas, we shall discuss on this. Now this is on trigonometric functions, right? Now we have one more thing, inverse of trigonometric functions. What are they? So I'll rub this. So those who are not copied, please pause it and pause this and copy it. So until then, I'll rub this. So inverse trigonometric functions. Inverse trigonometric function. First one, d by dx of sin inverse x. We'll study all this later. Now, time being, you copy this. If phi inverse, that is sin inverse of x is, that is 1 by under the root 1 minus x square. So, d by dx of sin inverse x is 1 by under the root 1 minus x square. To d by dx of cos inverse x. So this is minus 1 by under the root 1 minus under the root 1 minus x square. See here also, once again cos inverse starts with c, you get a minus value. Third one, d by dx of tan inverse x, that is 1 by 1 plus x square. If you differentiate tan inverse x, you get 1 by 1 plus x square. No root here, remember this. Fourth one, d by dx of cot inverse x. So this is minus 1 by 1 plus x square. Again, don't put, because it is minus, don't put it here. So it is minus 1 by 1 plus x square. Now sixth one, d by dx of secant inverse x. So that is 1 by x into under the root x square minus 1. So if you differentiate d by dx of secant inverse x, you get 1 by x into under the root x square minus 1. And lastly, I'll lastly 1, 2, 3, 4, 5, this is, sorry, 5 and this is 6. So d by dx of cosecant inverse x equals to minus 1 by x into x square minus 1. So these are important formulae, inverse trigonometric functions, where once again I repeat, d by dx of sin inverse is 1 by under the root 1 minus x square, d by dx of cos inverse x is minus 1 by under the root 1 minus x square, d by dx of tan inverse x is 1 tan inverse x is 1 by under the root 1 plus x square, d by dx of cot inverse x is minus 1 by, see again, minus 1 by 1 plus x square. Here again you are getting minus value. So d by dx of secant square is 1 by x into, here it is not 1 minus x square, it is x square minus 1. Don't get confused like this, but this is x square minus 1, not 1 minus x square. So most of you go wrong here, please be aware of this. And d by dx of cosecant inverse x is minus 1, see again 1, again you got, see again minus value. So minus 1 by x into under the root x square minus 1. So these are important formulae which you should remember while doing problems on differentiation. And this holds good even for integration, but the formula changes. Let us see how it changes. Okay. So please note down this and memorize this thoroughly, so that is very important for us. And before I finish, before I conclude, I request you to like my video, share my video and subscribe to my channel, so that you will be getting more of such sort of classes where I will be teaching you from basics. It will help you a lot. Remember what my funda is: learn maths from basics, and you will learn maths from basics from me. So with this note, I end the class today here and come back by evening or tomorrow. So until then, good day. Thank you for listening to this. Good day, dear students. Have a good day.